Hello again. Well, as you may know, I like LEDs. I like flashing lights. And this is my little setup at home at the moment. I've got the shelves above my bench. I've got my soldering iron and all that sort of stuff just there on the first shelf. And all my tools and everything on the main bench. And I like flashing lights. I like LEDs. I'm the sort of guy that goes to a pop concert or a concert of some sort, and I'm the guy who looks for the bulb that's out or the sequence that isn't quite right. But that's just me. I just like flashing lights. So what you're seeing above you at the moment, or above my desk at the moment, I've got 3 shelves with WS2812B LEDs in them, and they're behind a small bit of plastic just to diffuse it a bit. And those 3 are also connected to my bench. Let's have a closer look at my bench and I'll show you. I apologise for the brightness of the LEDs on the right hand side. Let's just push them to one side for the moment. So those LEDs there are also matching the LEDs that are on the shelf above you, just there. Okay, we're all happy with that. Those annoying flashing ones there are completely different. So what am I doing? Am I using 2 controllers? Am I using 6 controllers? How am I controlling those shelves, which are all the same, and that one, that's 4 of them, as well as those there? What's happening? Well, I tell you what, let's have a look at the bench and let me show you what's going on here. Okay, so on the bench, I've still got the LEDs on. Let me just explain what's happening on here. Just over this side, I've got a 12 volt transformer. So this is changing standard 240 volt in the UK power down to 12 volts. Over this side, I've got a 5 volt transformer. Again, it's just changing standard 240 volt over to 12 volt, over to 5 volt, sorry. I've got a LED controller here, and I've got an LED controller here. So that's 2 LED controllers, but I'm controlling 5 different things. How can I do that? Well, that's what these 2 boxes here are doing. Just very quickly to explain, because I will go through this in great depth. This controller here is outputting to 1, 2, 3 on this side and 1 on this side, which is actually this one here, sorry. And then this LED controller here is outputting on the very end one to this bunch here. So how come that this box here can output 2 different signals to LEDs? Well, that's what the beauty of these little two boxes are. You could have, for example, you could have just one controller here, and it could output to 4 channels here and 4 channels here. So you could actually output one controller to 8 different sets of LEDs if you wanted to. So why would you do that? Well, you might have a big room to cover, you may have Christmas trees to cover, you may have a garden to cover, anything like that. But these boxes here are amplifiers and splitters. Now, one of the questions that we often see on Facebook and the internet is, how do I split a signal? Well, you can split the signal using these boxes here. I know it looks like a bit of a mishmash of cables, but it's not as complicated as it seems. What I'm going to do, I'm going to clear all this out, we'll get one box and we'll start again from scratch. Right, bench is clear, so let's have a look at what we've got. Here is a roll of WS2812B LEDs, and this is the sort of stuff that I've got on the shelves behind some plastic to diffuse it. This is the LED strip, it's sticky on the back. You may have seen this plenty of times. We've got a ground, we've got a data, and we've got a plus 5 volt on this particular one. Let me just zoom in there a bit so you can see. Okay, and we've got an arrow pointing here, so the data goes in this way, goes to that LED, goes to that LED, etc. along the line. So that's the LEDs that I've got up on the shelves above my bench. So that's what that's there for. Put that over there. Okay, zoom back out again. These are the LEDs that I've got in the bunches. Now these are WS2811s. Now the difference between 2812s, which is these here, and these in here, is that the controller chip is actually embedded in this LED. So the 2812, the chip is embedded. 2811, the chip is external, which is just in there. These are also waterproof as well, these LEDs. These comes in bunches of 50. I've put links to everything down below, so you can have a look at that. So that's the LEDs there, another bunch of LEDs there. They all work on 5 volts. So bear that in mind later on when we start looking at the transformers and voltages. This here is a standard LED driver transformer. This is a 20 amp, 5 volt. It's a UK, so it's 200 to 220. I think what's the UK, 230 these days, 240. But that's the transformer that I use. You've got power from the mains going in here, live, neutral and earth, and then you got 2 grounds and 2 plus 5 volts to come out. There's a little trimmer down the corner here that you can just check that to make sure it is on 5 volts or 5.5 volts, etc. This is one of the controllers that I was using. We'll look at this later on. This is a SP901E. You can control this via USB, not USB, sorry, you can control this via Bluetooth, and we'll have a look at the app and the Bluetooth working on this later on. The other one I was using is one of these. These are dirt cheap. This is an SP, I think it's a 101. Doesn't actually say it on there. Just a minute. I've got another one over here. What's this one called? Yeah, oh, SP901E. So these are really simple LED controllers. This particular one, this black one by the way, has got a USB on it and with an end, so you can actually run LEDs from USB. But we're not doing that, we're using this one here. This has got a normal type of round socket for a power to go into there. Okay, so that's the 2 controllers that I'm using. The other transformer is this one here. Again, live, neutral and earth going in. This is transforming it from 240 volts down to 12 volts. So that's what that one is, just there. And finally, we have these 2 here. So I'm going to take one of them away, not to confuse you. Let's just concentrate on one of them only. So on this, we've got signal in, signal out, and outputs 1, 2, 3 and 4, and it says single signal amplifier there, SP901E. So first of all, let's have a look at the back. So at the back we've got VCC and ground. So this is where you've got your main power input on here. Power, it says on the front here, goes from 5 volt to 24 volt. It says it on the top there. Let me just zoom in so you can see that. There we go. So it says 5 volt, 24 volt just there. The consumption of this box is less than 1 watt. So we put our VCC, which is our plus voltage there, and our ground onto that one there. When we can power the LEDs, you'll notice it's got VCC and ground here. So if, for example, all our LEDs were 12 volts and we had 12 volts powering the controller here, then you can power your LEDs from the VCC plus 5 volt and the ground from the outputs here. If we wanted to daisy chain these to have more LEDs in the row, then we can do it by daisy chaining the controllers. So the signal out from this side would be looped to the signal in on this side, and again you've got signal out, and you can loop and loop and loop. So that's how you can have multiple strings of lights, but the only thing to bear in mind is they'll only show you what the input of the very first one is. Now, something that I've discovered in the testing that I was doing on the bench beforehand, although it says that it works 5 volt to 24 volt, when I got my LED lights, the signal amplifiers all connected up on 5 volts, it didn't work. The transformer here is 20 amps, had plenty of power in here to power everything, but it just didn't work. What I did then is I then thought, okay, what I'll do is I'll power the LEDs directly from the transformer and power this controller on 12 volts. That worked. So although this does work from 5 volts upwards, to me, my experiment, it seems to be a lot stabler with 12 volts. And I'll show you how all that splits up later on. So just bear that in mind, that if you are going to use these, or even multiples of these, it may be that you have to use 12 volt to power these and 5 volt to power your LEDs. So that's why I used this controller, this SP901E, because, and I'll zoom in a bit for you, this again can use DC 5 volts to 24 volts. So this range, 5 to 24, is the same as this one, 5 to 24. So I thought, that's okay. I can run the original controller plus a signal amplifier splitter and my other one. I can power all that on 12 volts and keep all my LEDs on 5 volts. And that seems to work. That seems to be a lot stabler. And that's how I had this setup done. This one here is also 5 to 24 volts, but what I did, because I wanted to test running 2 signals, I only ran that on 5 volts just to test it to see if it worked. So it's a mishmash of power, and if you get it right, it works absolutely fine. If you get it wrong, you can release the magic smoke that's hidden in all electrics, and you'll find that things don't work. But hopefully I'm going to take this step by step over this video and the next. So I'm going to split this into 2, and I'll show you how to connect all this up and get it working. I must give you a warning though. Everything I'm going to do on the bench over the next couple of videos is just working on the bench. I strongly advise that if you do this for your garden, for your Christmas trees, for your theatre group, for your school, anything like that, you must have inline fuses. What I'm going to do is I'm going to show you a board that I made before with LEDs on it, and I'll show you how I've got the LEDs in line. So I emphasize again, when you're going to do this in a commercial setting or anything like that, school, theatre, you must have inline fuses. But because I'm only working on my bench and I'm just going to show you how to set this up, I'm not going to use fuses. Yep, okay, let's crack on. So here is the example that I was talking about. I'll show you the front in a moment. So this has got 1, 2, 3, 4, 5 transformers on it. Mains power comes in there and gets split between the 2 sides for the power for the mains. Here you can see that we've got a block with all the grounds connected together. So any ground within the controller itself, the lighting rig, all the grounds go through that. And above that we've got a bank of fuses as well. So all the fuses are connected to the outputs of the transformers. You can see there's 2 plus 5 volts coming out of here and 2 grounds. So if we follow the red cable, it goes in this bit of trunking up there into the here, and then it goes out again to the LEDs via these chop blocks here and in to the back of the unit there. Look, you can see. And just the same as the grounds, like I say, all the grounds, all the white cables here, you can see a blue cable here, any grounds are all connected back to the central place as well, which is there. So that's the sort of thing I'm talking about when we talk about making sure that anything is fused. Anything that you do like this sort of lighting is fused. By the way, the controller's up there. We've got a Smart Show controller. And that again, all these are your outputs for the different universes. This is the power, and I've just mounted it on this board here for ease. The cables come out the controller, and I've soldered them onto the board and put these screw connections on it, so it's easy just to get the outputs on it. What I'll do is I'll just pause the video, spin it around, and then you can see the front of it as well. Right, I've turned it around and now you can see the LEDs on the front, which are just using the normal colour scroll. So it is made up of 3 panels across the top, 1, 2, 3, and 3 panels down the side, 1, 2, 3. So 1, 3, 3, 2, 3, 6, 3, 3 is a 9. So that's 9 panels of LEDs. These LEDs are 22 by 22. I'll just zoom into the one that's not turned on the bottom corner there. There we go. And this gives you a picture of 66 LEDs across there by 66 LEDs across there. And these are 2020 as opposed to 50-50. Just a moment. Right, so the LEDs in something like this, the normal roll of them you get, are what's called 50-50, so it's 50 millimeters by 50 millimeters per LED. These, however, are 20-20, so you can see they're a lot smaller, which means you can get a lot more in the actual inch or the pitch. So that gives us a bit more imagery. Right, let me just change the pattern for you. Right, hopefully you can see it all right. I've actually got the curtain open at the moment because sometimes if you have bright LEDs, it can swamp out the camera. But as you can see on there, we've got another image of a Rubik's Cube going around. So you can see you can change the more LEDs that you've got, the more clarity of the picture that you can see. Let me just close the curtain and see if that actually helps anymore. Right, I've closed the curtain, but it's a bit of a bright day, so it hasn't really helped. But as you can see, there we go, that's the LEDs working. I say I have not connected the bottom one so I could show you what a panel looks like and the LEDs themselves. Can I zoom in on LED? There we go, there's the LEDs actually working. Right, let's get back to our project on the desk. Right, we're back on the bench again. So we're going to connect this signal amplifier up to a transformer, and then we're going to connect our controller in as well. So I've already got it connected to the mains, which is just here. The mains is turned off at the moment. So we're going to connect our plus 5 volts to here. And we're going to connect our ground as well. Okay, and we're going to connect them into the back of this where it's got VCC and ground. So the ground connection goes in. Like so, and then the VCC or the plus 5 volts goes in as well. Making sure that's nice and tight. There we go. So that's got them two connected up. Right, next thing we'll connect up is our controller. Now that has a male connection on it, so we'll need a female connection. to go from there to the back of the unit. Again, we've got a signal in here, so we've got VCC, which is our plus 5 volts. We've got our data in 1, so it says DAT1, so that goes in next. And finally, we have our ground cable. Oh, our data cable's popped out, so let's just do that one again. And as I was saying, we'll put our ground cable in. Now, here is a warning. So, what you've got to be careful of is if you ever look at the wiring diagram on the internet for some of these controllers, it will show you that the plus wire, the plus 5 volt, is connected here, and your controller is connected on the controller as well. Do not do that. If you have power going from here to your controller and power going into here, you will blow your transformer. Not your transformer, you will blow your controller. This is because the VCC here is a plus 5 volt output. That's not an input, that's an output. And if your controller can be controlled, can be powered by the VCC here, then this will power into here. If you want to power from this side, as in an external power supplier, do not connect your red wire or your VCC this side. Just remember, controller is only one power source, not two power sources. Don't power both sides, otherwise you will blow it. I've seen numerous wiring diagrams on the internet which are completely wrong, so just be very careful about that. I know that this controller can be powered through the red cable back into it this way, so that's why I'm doing it like that. Again, be very careful about that because it can catch you out. Right, next thing we need to do is connect some LEDs up. So I'm trying to find my LEDs, and here it is. So just the same as before. Ground goes in. Signal cable goes in into DAT1. And our power goes in as well. There, very straightforward. So we've got transformer, we've got a controller, we've got our signal amplifier, and we've got our LEDs coming out of it as well. Right, okay, so we're going to turn on the power, and we're going to use this software called Magic LED, and it's picked up the SP901E just there, look, so we can click on that. It says connecting, and it says connected. It connects via Bluetooth to the controller. We can change the colour here if we wanted to, or we can leave it as auto. So it's on auto at the moment. So that's okay. So that's showing that we've got power going to the controller, and it should be controlling the lights at the moment. So let's have a look at the lights. And I'm going to have to take the camera off the stand, so bear with me for a minute. And there we go, right at the top there you can see LEDs up there are being lit. Right, okay, back on the bench. So we know that everything is working as it should do. Right, we'll switch the power off, and then we'll connect another set of LEDs. So let's use this bunch here, and we'll need a little adapter. Here we go. Right, so just as before, we've got the ground, the data and the power plugged in there. So let's connect that up and we can switch on again. And we're connected on there. And again, we can change the colours if we wanted to. And we can go for auto. And as you can see, here we go, we have lights flashing there and lights flashing there as well. So that's all working okay. So now we've got two sets of lights running off just one controller here. Okay, what we've got to do now is to add some more LEDs. Right, I've turned the desk lights off again. So just as before, we've got the LEDs connected into here. We've got the ones on the bench plus the ones above the bench as well. So let's power on and we'll go into our software and we'll pick up the 105. Now, one thing you'll notice, the LEDs are lit. Let's just change it to green or red, or we'll put it on auto. Although the phone says it's connected, we've got nothing coming out of here. So we'll look at the shelves and there's no LEDs on the shelves either. So you could say, okay, are we powering it? Well, let's have a look. And if we go, I'm going to turn the lights on, so just watch your eyes. Okay, the lights are back on again. And if we check between the power and the ground, oops, help if I put it into voltage mode, won't it? Right, power on the ground. You can see that we are pumping out 5 volts. But we are not getting anything on the LEDs here or the LEDs on the shelves. So why is that? That's 5 volt, that 5 volt, that 5 volt, and that's 5 volt. Well, I think it's simply that even though I'm on a 20 amp transformer, this is pulling too much power and it's not sending enough out to the LEDs. There could be another explanation for that, but that is what I found when I'm doing my testing. So I think the best thing we can do for this is move the controller and this box onto 12 volt and leave all the LEDs simply on the 20 amp 5 volt transformer. So let's have a look at that now. We'll turn the power off first. Okay, let's have a quick look at our power that we're going to be drawing. This is just a quick overview. You may want to set up your own spreadsheet as well, just to double check your figures and make sure that your calculations are right. What we do is we set a value per pixel of about 0.6 amps per pixel, 0.06 amps per pixel. Then we need the number of pixels that we're going to be powering, and that will give us a total number of amps. So on our desk we've got 45 LEDs per shelf. That's on the edge of the shelf. So that's 45 LEDs times 3, which gives us 135 LEDs for the shelves. The bunch of LEDs is a total of 50 LEDs. So we've got 50 LEDs in that bunch. So let's do a quick calculation. And that is just the sum of those two. So we've got 185 LEDs in total. So let's put that in there, 185. And we can work out the number of amps that we've got here. And that's simply a calculation of the amps per pixel times the number of pixels. So that comes to 11 amps in total. We're running 5 volts for the LEDs, and we can use the amps times the volts, which gives us the watts. So if you want to, if your transformers works by watts, mine gives the total of 20 amps, but if you go by watts, so we're going to be pulling 55.5 watts or 11.1 amps. That is assuming all the LEDs are on full brightness and are white. In other words, the red, the green and the blue are on total brightness. And that's how you need to calculate it. I would strongly recommend you never ever do that. You'll never run 100% brightness on all your channels. But what you need to do is to calculate using to make sure you've got enough transformer power as if it was that. If you want to work out the amps and you've only got the watts and the volts, we can just use a similar calculation. So on this we've got 55.5 watts and we've got the voltages of 5, so that gives us 11.1, and that's simply the total amps is the watts divided by the volts, which gives us the amps there. So you can double check your calculations both ways by converting from your individual pixels, total amps, total watts and total watts to total amps. Hope you understood that. If not, just rewind the video, go through it again. These calculations are available on Google as well. Just do a quick search, but a simple spreadsheet like this can save you a lot of time by just calculating how many LEDs you've got, what your voltages are and what your total amps are. Now when you're thinking about that big LED matrix that I've got, that I showed you at the start, that's why you need this sort of the 5 transformers to power all those LEDs. Right, we're back on the bench. So first thing we need to do is to make sure that we disconnect everything. The power is off at the wall, so let's disconnect all the connections. Let's just move the lights just to one side, out of the way. So all we've got is the transformer, the controller and the amplifier splitter there as well. So what we're going to do is we're going to power just the LEDs from the 5 volts and the amplifier splitter and the controller from 12 volts. And this is how we do it. First things first, let's disconnect the power from here. So that's now the 5 volts removed. And what we'll do now is we'll bring in our 12 volt transformer. Again, this is disconnected from the wall, and we'll connect the 12 volts to our amplifier splitter. So that's the VCC or the plus 12 volts in, and then we'll stick the ground in. In fact, we won't flick the ground in, we'll do another little job first. What I'm going to do is get a little chop block like this, bum, 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 and we're going to put it in here first, and I'll explain why we do this in a moment. We need another cable, and in the true sense of Blue Peter, here's one I prepared earlier. We'll put that in there. Okay, and we'll put that and in our connector like so. So that's got the 12 volt ground coming from here to our little chop block here, and going from the middle one to here. It's not called a chop block, is it? It's called a, oh, I can't remember now. It's some complicated thing. It's a one of them. There you go. Right, okay, so let's get back to what we're doing. What we'll do now is we'll connect this ground from the 5 volts to here as well. Now, it is important to remember you are only connecting the grounds together. You do not connect the plus 5 volts to the plus 12 volts. You only connect the grounds together for this to work. Okay, got that? Good. Right. What we'll do now is we'll disconnect the plus 5 volts, the red, from the outputs here. So that's the plus 5 volts to go into our LEDs, all disconnected. Or get another little block like this, and we'll put them in here. So that's the first one, and that's the second one. And that is the third one. And that is the, where I can get it out, fourth one. Right, so all the plus 5 volts that's going to the LEDs are now connected to this block here. 1, 2, 3, 4. 1, 2, 3, 4, and then we connect the plus 5 volt to here as well. Okay, so let's just do a quick recap so you're happy you know what's going on. We have got 12 volt ground going to this connection here, 5 volt ground going to this connection, and then both of those go into the ground here. You've got to have the ground of your transformers connected together as well as your controllers. We have got the 12 volt powering the splitter amplifier, and using the VCC out on here is also going to power this. Make sure that your controller is capable of receiving the high voltage. It says on here that this goes from 5 volt to 24 volt. That's okay. This says 5 volt to 24 volt. Okay, so that's okay. So these two are all right on 12 volt. We're not powering the LEDs on 12 volt. They are coming from the 5 volt transformer to this block here, which is then feeding through to all the connections here. Now, if your LEDs are 12 volt, you're absolutely fine. You can run everything from your 12 volt transformers. Mine aren't. Mine are 5 volt LEDs, 12 volt controllers and splitters. Are you with me so far? Good. Right. Okay, before I plug anything in, I'm going to switch on. Make sure there's no big bang. So first of all, I'm going to switch on my 12 volt and just double check to make sure that we've got 12 volt coming through. Yep, if you can see that, it says 11.4, 11.5. That's okay, so that's 12 volt coming through. And now we'll switch on our 5 volt. Great, there's no big bang, that's okay. So we'll just double check to make sure that we've got 5 volt. I'll just poke it in there and there. Oops. And we've got 5 volt on there, so that's okay. Power going off on those, so that's the power now off on that. Right, let's connect these up. to here. So we've got number 1 on there, number 2 going there, number 3, wherever it's disappeared to, there it is going in there, and then this one here connects to our bunch of LEDs like so. Obviously it goes without saying that if you're doing this outside or something like that, you'll have a lot more cable to play about with rather than just the short cables that I'm using here. Right, desk lights going out. Okay, so we're going to turn the 12 volt on first. That's on first. You can see a LED has just powered up here, so we know that's on. We're going to switch the 5 volt on now. There we go. And we've got lights working. So lights are working there, and lights are working on the shelves as well. And that's instant. That was straight away a start, and that's because the 5 volt transformer is only powering the LEDs, and the 12 volt is only powering the controller and the splitter amplifier as well. Okay, so that's it for part 1. I'll let you absorb that. What we'll do for part 2 is we'll show you how to add another one onto here, and we'll have more LEDs and more flashing lights. Thanks very much for watching. If you like what I do, please give me a thumbs up, please subscribe, and if you get a chance, all this talking is making my throat dry, so can you buy me coffee as well. Catch you soon. Thanks very much for watching. Bye for now.